Welcome to Maths and Science by IITian channel. In this video, I will be discussing about the rotational motion lecture number 3, where I will be taking up the acceleration. In the last class, as an introduction, it was a very lengthy lecture for about more than 1 hour. In that, I have discussed about the physical meaning of the Newton's laws, Galileo experiments, and also translational invariance and rotational invariance, and what is the meaning of translation and what is the meaning of rotation. Translation means variance in the position. Rotation means variance in the angle, and both I have discussed at length, and for clarity you can check my last video. And in this video, in the last video I was supposed to derive the velocity equation, which I could not do because of the length of the video. It was very long. Now in this I will be taking up not only the velocity and the acceleration in the rotational motion. Velocity equation which I have given in the last class was V is equal to dr by dt and r cap plus r into d theta by dt into theta cap. Why this r cap and theta cap have come? Because there are two variances that take place in the rotational motion. Not only in the linear but there will be angular displacement also. Angular displacement is due to change in angle, that is theta. And linear displacement is due to displacement of r. That we have to find out. This I have shown it as a rotational motion for an axis for a rigid body in a circular, but the figure can be like this, the diagram. 3 degrees, x-axis, 3 axis, y-axis and z-axis. The point can be somewhere here, and this point P is x, y, z, and this is r. R need not be fixed. There is a translational moment. Whenever there is a translational moment, R changes. Whenever there is a change in angle, then there will be a rotational moment. Because of the rotational and translational moment in rigid body motion, we consider not only the linear dimensions, we will consider the angular dimensions also. Linear displacement and angular displacement. When we consider, from the basics of differentiation, d by dx of a function, product of a function. If u is equal to function of x and v is also a function of x, then d by dx of uv is equal to d by dx of u into v plus u into d by dx of v. Famously it is written as uv dash is equal to u dash v plus u v dash. From your basic differentiation, I think you know this. If somebody doesn't know this formula, you can use this formula and find out that v is equal to What is the velocity? Here this is first function and second function. Don't confuse with v here. Here v is equal to velocity. Velocity is rate of change of displacement. Rate of change of displacement. That is equal to d by dt. Rate of change of displacement is r. R is the displacement. Rate of change of displacement is d by dt of r. Vector r. Vector r, how it can be shown? Magnitude r into unit vector. That I have already told you in the vectors. Magnitude r into unit vector. That is r cap. Now here we have to differentiate r and also r cap separately. That you should make a note of it. R and r cap. This is u, this is v. First function and second function in this equation. Then velocity v is equal to d by dt of first function, that is d by dt of r, magnitude of r, into cap, r cap, plus magnitude r into d by dt of r cap. You should understand this. R is the displacement here. We can take, instead of r, you take x, no problem. Call it by any name. Shall I call it by x? You call it by x. And theta. There is no problem. Here it is p. You call it by t. Displacement r. We will call it by r usually in the rotational motion. That's a convention. You can call it by any name. Don't worry of calling by symbols. Don't worry of the symbols. Let me call it by y. Let me call it by x. Or let me call it by z. What is wrong? Z usually we will use it for complex numbers. Now, when you do rate of change of unit vector, rate of change of unit vector is, this can be written as dr by dt into r cap plus r into dr cap by dt. Can we write dx by dt is equal to dx by d theta into d theta by dt? We can write. Please remember this. Similarly, dr cap by dt is equal to dr cap by d theta into d theta by dt. Please remember this. In this case, what happens? Dr cap by dt is equal to dr cap by dt is equal to dr cap by d theta into d theta by dt. D theta by dt is nothing but angular velocity. That implies When you substitute these values in the original velocity equation, vector velocity is equal to velocity vector is equal to, it is velocity vector is equal to dr by dt r cap plus r into dr cap by d theta into d theta by dt. Then what is the dr cap by d theta? That is theta cap. But dr cap by d theta is equal to theta cap. That is unit vector of angular displacement. This is the unit vector of linear displacement, translational. This is unit vector of angular displacement. Hence, this can be written as dr by dt plus r into d theta by dt into theta cap. Hence, the velocity vector is equal to dr by dt r cap plus r into d theta by dt theta cap. This is the final equation for velocity vector. And here you see, this is due to displacement or translation, and this is due to angular displacement, that is rotation. That means v bar is equal to velocity due to translation plus velocity due to rotation. Here we have proved that the net velocity of a particle on a rigid body which is under rotational motion, the velocity will be sum of the rotational and translational velocities. In a linear motion, when there was no rotation, it was only simply a translational motion, velocity. But in case of rotation, the velocity is due to translation and also due to rotation we have to take in case of rigid body rotation. In case of a rigid body rotation, the velocity due to translation and velocity due to rotation both are to be considered. Similarly, same is the case with acceleration also. Same is the case with acceleration also. For acceleration, this is equal to AR plus A theta. Due to translation also, there will be a, this is due to rotation, this is due to translation. Don't worry about the names. This we will call it as, instead we will maintain a we will maintain a similarity in both the notations. This we will call it as Br, because of this R, that is translation, and B theta because of theta, that is angular, because of theta, and this is because of R, that is displacement. Similarly for the acceleration also, because of the translation and because of angle. This is due to translation and this is due to angular displacement. This is due to translation and this is due to angular displacement. When we start doing the problems, we will be able to understand better and deep dive into this acceleration when in the rotational motion, when rigid body is in the rotational motion. We will do some problems here and then we will understand what is what. And another thing, in the acceleration there is something called Coriolis acceleration. Coriolis acceleration is nothing but the change in r and change in theta are not independent. There will be combined effect of dependence of linear and also angular displacements, and there will be an additional displacement, additional acceleration factor, that is called as Coriolis acceleration. That also I want to mention. That is denoted by two into dr by dt into d theta by dt. If you are comfortable with it, this type of notation, dr by dt, that is velocity with respect to change in the displacement, into rate of change of angular displacement gives rise to into theta cap is the Coriolis effect. This is because of the interdependence or interaction between, you just see here, dr by dt is also there, d theta by dt is also there. They are not independent, they are dependent on each other. The product of these two into 2 theta cap gives the Coriolis effect. And the final equation for A is written as d square r by dt square. This is a regular acceleration due to displacement, linear displacement, minus r into d theta by dt whole square r cap plus r into d square theta by dt square plus 2 into dr by dt into d theta by dt theta cap. This is the final equation for acceleration. Here this is due to translation, this is due to rotation because of theta, change in theta, because of r, change in r, translation and rotation. This is the acceleration, net acceleration. In this particular part is, you just see, in case of velocity this is not there. Product of dr by dt and product into d theta by dt. This product of these two is interdependence, or because of the effect of one on the other. Because of the double effect of r and theta, this is Coriolis effect. This Coriolis effect causes lot of changes in the weather because of the rotation of earth, and those things we'll see as we progress in the mechanics. And this is what is the class, today's class, and I thought I'll give the brief of rotational motion and derive some equations. From next class onwards, we'll be taking up the numericals up to what we have learnt in rotational motion. We have not yet come to the calculations of moment of inertia. That we will take up after some numericals. Some 3-4 classes we will do numericals on rotational motion on this topic. What are the topics we have covered till now? One is that we understood what is the rotational motion and how the velocity in the rotational motion will be found out. What is the translational displacement? What is the rotational displacement? What are the equations for the rotational displacement and translational displacement? And how the vectors can be used for finding these velocities and accelerations. And we have good number of questions. I have got a collection of good number of questions on this topic. Definitely in the next class we will take up. Best of luck to everybody. Thank you for listening to me. And my previous class was a little bit long class. Please listen to it carefully. That is very, very important. Once you understand that, you will be able to understand the following chapters. This is a very small lecture, and please go deep into this lecture and understand why these equations have come and how these equations have come. Refer to a standard textbook and try to derive on your own. I have derived, but still you try to derive on your own, especially for acceleration. And next we will be taking up the numericals. Best of luck. Thank you. Please, if there is a value addition due to this lecture to your knowledge, please subscribe to my channel and share my videos to others also, so that they get benefited. Thank you. Best of luck.